Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy, and I'm Jeetendra Dixit. So, before we begin, let me check my voice first. Alright, so as you know, now this is my profile. So, let me introduce myself. I did my BTech from IIT Kanpur, and I've been mentoring IIT-JEE aspirants for the last 11 years. Okay, so I teach mathematics and we were doing straight lines. So this is the fourth session and today we'll do locus. Okay, so we'll do locus and then after that we'll start equations of straight lines in the following lectures. Now, before we start the topic today, let me tell you about the Unacademy subscription also. So as you know, Unacademy is India's largest online learning platform, and if you subscribe for Plus, then you can have two types of subscriptions on Unacademy. One is Plus, another is Iconic. So let me tell you about the Plus subscription first. So if you are subscribing for Plus, then you get unlimited access on the platform. You can watch uh, live sessions of any educator. You can follow their courses. So well structured courses are going on for droppers, for 11th class students, and for class 12th class students. Various courses, a lot of courses, and even every week new courses starts. Every week, a lot of new courses start every week. So you can join a fresh course or you can join ongoing course. You have complete freedom on the platform. You can follow educator of your choice, no restriction. You can join any batch. All right. So this is the access you get when you have Plus subscription. All live tests and quizzes will also be accessible to you, and all the courses are well structured. Now these are the subscription charges. For 1 month you have to pay 7,000, and for 3 months, 6 months, 12 and 24 months you can see the price list. And after 10% discount, it is going to be this is the final price list after 10% discount. So 12 and 24 months packages you can compare. These are economically better packages. Per month you can compare. Now this is the iconic subscription. So iconic subscription, in iconic subscription you get all the benefits of Plus, and apart from that you get a personal coach who will guide you throughout the preparation for IIT-JEE. Your test analysis will be done in a personalized manner. Personalized feedback will be given to you to improve your time management and exam approach. And your study planner will be customized. All right. Bi-weekly reviews will be given, highlighting your progress. So this is iconic subscription, and you get this iconic subscription in 56,000 for 2 years, for 1 year, sorry, and 86,000 for 2 year. Okay, and you get 10% discount in these two also. Now this is Unacademy's learning app which you can download from Play Store, and after downloading it, you can start your preparation. Uh, Even without subscription, you get a lot of stuff for free, like special classes you can attend for free. For special classes also, you will have to use this code JEET1. So use this code JEET1, okay, and you'll get access to free special classes. So you can attend unlimited free special classes on the platform, and quizzes as well. A lot of quizzes are also going on. You can attend those quizzes also. So from 1st of December, you'll have to use this code JEET1 to enter. Uh, to access those free stuff. Now this is Unacademy's learning app which you can download from Play Store, and after downloading it you can start your preparation. Okay, just make your account, use that code and start. And whenever you feel that you need a subscription, then you can buy subscription also. Now let's begin today's session. So as I was telling you that we are going to do locus today. Huh? Hi Arun, how are you? I'm good, I'm good. What about you? Okay, so today we are going to discuss locus. So let me tell you about the locus first. Locus of a point, locus of a moving point. So in coordinate geometry, in general, locus means a path, right? So locus of a point, that means path traced out by a point. So locus of a point is path. Locus of a point is the path traced out by the point under some given conditions. Yes, some conditions will be given. Otherwise, if point is random on the plane, then there won't be any fixed path. So under some given conditions. Okay, and equation of that path is called equation of locus. Equation and equation of the path is called equation of locus. Okay, so mostly we need to find equation of locus. Sometimes they just ask what is locus, whether it is a circle or a line or ellipse or parabola or some other curve. Okay, and sometimes and most of the times they ask for the curve. Okay, the equation of that curve. So what is that equation? Let's figure out. So first, let me give you some example. First example, locus of a point. Locus of a point moving in a plane and at a fixed moving in a plane such that its distance from a fixed point is always constant. Okay, so this is the first and very basic locus, and you all know this. What is this locus, right? So locus of a point which moves such that its distance from a fixed point. So say O is the fixed point, or maybe this is the fixed point, say. Okay, and a point, this P is a moving point. P is a moving point. P moving point, and P is moving in such a way that its distance from the fixed point is always constant. So locus of this point will be a circle, right? You all know that. So this distance will be given to you. If this distance is given, say R, okay, then it will be locus of P will be a circle whose center is at origin and radius R. Okay, so this is the locus. Now I'll tell you some standard locus first. So you need to remember those points. Now, second point is locus of a point. These points which I'm just mentioning here are very important in many chapters like complex numbers, like vectors. Okay, so in whole syllabus of IIT-JEE, these points will come again and again. Okay, so just take care of these points. Just remember these locus which I'm just mentioning here. Locus of a point, locus of a point which moves such that its distance it is equidistant. It is equidistant from two fixed points. It is always equidistant from two fixed points. All right. So now you can see, say A and B are two fixed points and P is a moving point. Then how would this point P moves? Then P will move on a line which is basically perpendicular bisector. Okay, this is the locus. So now in this case you can see locus of P is a line which passes through the midpoint of AB and perpendicular to AB, right? You can see always P will always be equidistant from A and B. All right. Now this is the third point. Locus of a point. Now let me give you the next one. Locus of a point which moves such that sum of its distances from two fixed points is constant, and now it has two separate conditions. Second condition is the second condition I am writing the first case. So in second condition, first case is that and distance between fixed points and distance between fixed points is less than the sum of distances. Sum of distances or the constant you that's because sum of distances is constant, so that constant should be greater than the distance between fixed points. Okay, so let's say A and B are the fixed points and P is a moving point. Okay, P is a moving point, so PA plus PB is given constant and that constant is greater than AB. Okay, that is the second condition. Okay, so in this case locus of P is an ellipse. Locus of P is an ellipse, remember that. Okay, locus of P is an ellipse, and ellipse is like this. Although we are not going to use properties here, just mentioning this locus, if sum of distances of a moving point from two fixed points is constant, PA plus PB is constant, and that constant should be more than AB, then only this triangle will be formed, right? Then locus of P is an ellipse. Okay, locus of P is an ellipse. So I hope this point is clear. Okay. Wait a minute. Let me just shift. Rearrangement. Okay, so now next point is, now the second case in this is if PA plus PB is equal to constant and that constant is equal to AB. So basically if I combine these two conditions, that means PA plus PB is equal to AB. Okay, then locus of P, what will be the locus of P? See, this is A, this is B, okay, and P is moving in such a way that PA plus PB is equal to AB. Then you know P will be anywhere between A and B. P will be on the segment AB. This is the locus. This will be the locus. P will be anywhere between A and B. So you can see PA plus PB is equal to AB. Okay, so it's a line segment AB, line segment joining A and B. It's as simple as that. Third. Now suppose A and B, next locus I'm telling you, if A and B, if A and B are two fixed points, and subtend a fixed angle theta on a moving point P, then locus of P is, okay. See, in all such cases I'm just telling you the locus, okay, not writing the equation. After this we will start we'll start finding the equation of locus, okay. So in this case locus of P is an arc, okay, arc of a circle, of course. So in this case locus of P is an arc. I'll tell you how. See, these are two fixed points and this is an arc. Say, it depends, it's a major arc or minor arc, that will depend on theta. What is this angle theta is given? So if this theta is, say, this is A and this is B, okay, this is A and this is B. So you can see this angle, take anywhere, this angle is always constant. You have done this property, right? Chord AB subtends equal angle, right? This angle is theta. You take P anywhere on this arc, this angle is going to be theta. So there will be an arc which will subtend, say theta is 60, then this is going to be major arc. If theta is 120, then more than 90, then this will be a minor arc. It can be a minor arc, depends whether theta is acute or obtuse. There can be another arc, there can be two arcs. One can be reflection about AB. So same arc you can draw below AB also, alright? Same size. Size will remain same. So this is another case. So two arcs, okay? Two arcs are possible. This is also the locus. So same size arc, this is arc of same size, just the opposite side of AB, line AB, okay? Or you can say if you join line AB, it's this, these two arcs are reflections of each other about this line, right? So these are the possibilities. It can be on the upper side arc, which is on the upper side, that means arc number 1, or on the arc number 2, okay? So P can be anywhere on these two arcs. These two arcs can be major arcs, both will be major or both will be minor, right? So this is again a very important point, and this becomes a very important point in complex numbers also. Okay. Now let me tell you one important point. This is the last point and very important point. Locus of a point which moves, locus of point P, okay, which moves such that ratio of its distances from two fixed points A and B is a constant, okay, is constant, say K, where K is not equal to 1, two fixed points A and B. That means PA upon PB is equal to K and K is not 1. Then locus of P is a circle. I'll tell you how. Okay, so locus of P is a circle. Good afternoon, Gia. I just started Locus. I think you know Locus, right? So I was just mentioning Locus of a few points. Like in this case, do you know if a point moves in a plane such a way that ratio of its distances from two fixed points was a constant, then it moves on a circle actually. This geometry is very important. So P is this point. Now let me tell you that it is given that PA upon PB is a constant, okay? PA upon PB is a constant. This is given. PA upon PB is a constant. K. And K is not 1. So let's take K more than 1, okay? K more than 1. K can be less than 1 also. It can be 0 to 1 or more than 1. So if I draw the angle bisector, I'm drawing two angle bisectors here. I'm trying to show you that this locus P moves on a circle, okay? But how? It should satisfy some property of circle. So I'm drawing the angle bisector of this angle, internal angle bisector, okay? So you know internal angle bisector bisects the opposite sides in the ratio of remaining two sides. So remaining two sides ka ratio is k is to 1, k is to 1. So this ratio is also going to be k is to 1. Internal angle bisector of a triangle bisects the opposite side in the ratio of remaining two sides. Do you know that? Okay, Jim. So this ratio is k is to 1 because A and B are fixed point. K is a fixed constant. K is a constant. So this point C will also be fixed. This point C will also be fixed. So C is a fixed point, right? No matter uh, where is P, it does not depend on B. Fixed point. All right. Similarly, if you bisect this another angle, external angle bisector. This external angle bisector will also say meets this line AB at point D. Then D will also divide A and B in the same ratio k is to 1, but externally. Now D divides, so that means DA upon DB is equal to PA upon PB. Okay. So D, this external angle bisector also divides the opposite side externally in the ratio of remaining two sides. So that is k is to 1. So this ratio is also k is to 1. Okay. This is also k is to 1. Now this is k because k is more than 1. So D will be which side? Right side of B. If k is less than 1, this point D will go to left side of A. That's the only difference by taking k more than 1 or less than 1. Okay, so this is point D. Now do you know that internal and two bisectors of lines, two lines, suppose these are two lines and these are two bisector. One is acute angle bisector and other is obtuse angle bisector. These two bisectors are always mutually perpendicular because this angle is going to be 90 degree. Okay, this is half of acute angle, this is half of obtuse angle, and sum of acute plus obtuse is 180. So sum of their halves is going to be 90 degree, right? So this angle is going to be 90 degree. This angle is going to, this is a very, very good geometry. This angle is 90 degree, okay? So now you can see that C and D subtend, C and D, these 2 points subtend a right angle at point P. So I've told you here that if two points A and B are two fixed points and subtend a fixed angle theta on a moving point P, then locus of P is an arc, right? And if this angle is 90 degree, if A and B subtend 90 degree at point P, then this is going to be semicircle, right? This is going to be semicircle. In fact, this semicircle will be downwards also, so it will make a complete circle. Okay. So using this, now you can say because C and D are subtending right angle at P, then locus of P is going to move on this circle. Move on this circle. Okay, circle is like this. So locus of P is a circle. A and B are not the diametric endpoints, okay? B is inside the circle and A is outside the circle. Okay, so I'm repeating this. This will be very important in complex numbers. I'm telling you, this is very important in complex numbers. And in general, we are going to remember this. Locus of a point which moves in such a way that ratio of its distances from two fixed points is constant, and constant is not equal to 1, because if constant is 1, then locus is going to be perpendicular bisector, right? Yeah, it's a locus of P, so P is of course on the circumference, and CD will be the diameter. Yes, CD is going to be the diameter, and we will express later CD in terms of AB. Again, complex numbers we will do that. You just need to remember this geometry. That's it. So locus of a point with P which moves such that its ratio of its distances from two fixed points A and B is a constant K, and K is not 1. Okay. Then locus of P is a circle. So P is moving on that white circle. Okay, is this okay? This geometry is clear? This sometimes they ask that B is inside the circle or A is inside the circle. Then how do we answer? Whichever side, if PB is less than AB, PB is less than AB. See, if PB is less than AB, that means circle is towards B, right? External division wala jo point है D, that will be right side of B. So B is going to be inside the circle. If PA is less than PB, then circle will be this side. Circle. If this PA is less than, if suppose diagram would have been like this, PA and PB, triangle is like this, PB is greater than PA, then circle will be like this. Okay. Then A will be inside the circle. All right. Okay. So now we will learn how to find the equation of a circle. So I'll tell you certain steps. Equation of locus of a point. Now this is very important. Most of the students remain confused while finding the equation of locus. You need to always follow certain steps. The first very important point is assume the coordinates of the moving point to be h comma k. Okay, by the way, what is equation of a curve? Equation of a curve is a relation between both x and y coordinates of a moving point on that. Suppose this is a curve, okay, and P is a point on that curve, say x comma y, a variable point which is moving on that curve. So equation of this curve is nothing but a relation between x and y, a relation which is between x and y involving constants but not any other parameter, because if any other parameter is involved, then that equation will start varying. Then it will not be a fixed equation, so it will not represent a fixed curve. Like if I write x square is equal to 4y, this is equation of a fixed curve. We'll later learn what is this curve. If you have done quadratic, then you know it's a parabola. But if I write x square is equal to ay and I say a is a parameter is again a variable. Parameter is an arbitrary constant we call. So if a is a parameter, like a can take value 2 or 3 or 4, then this parabola is not fixed. This is not a fixed curve, right? So in equation of locus of a point which is moving on a fixed curve should not involve any parameter. I'm repeating. Equation of a curve, equation of locus of a point which is moving on a fixed curve should not involve any parameter in its equation. That is the simple rule, okay? Remember that. So, and what is equation? Equation is a relation between x and y coordinates of that moving point. So what are we taking x and y coordinates? We are taking x and y coordinates to be h comma k, h comma k. That means we are going to make a relation in h comma k. See, make these points very clear in your mind, that what actually you need to do while finding the equation of a locus. If these are 2-3 points, if you just understand these 3 points clearly, then you will never face any problem. The first point is assume the coordinates to be h comma k. Do not take x and y, because maybe while finding the equations you will use other equations also, and the other equations generally you write in x and y. So you will get confused. Your x and y and that equations x and y, they are different actually. So to make that differentiation, we are taking h comma k. Okay. In the end, we will put x comma y in place of h comma k. So the second step is after taking the coordinates of this point to be h comma k. Now the second point is apply the given conditions. Apply the given conditions. Given conditions means what? While defining the locus equation, while defining the locus of a point, I told you that it is locus of a point is a path traced out by the point under some given conditions. Some conditions will be given, some restrictions will be given. Like in the previous example, I was telling you that P is moving in such a way that ratio of its distances. So that was the condition. So after assuming the point, you need to apply the conditions. If there's one condition, you will apply one condition. If you have the two conditions, you'll apply two conditions. Okay. And while applying the conditions, you might have to assume some parameters. Maybe you'll have to assume some distance. Maybe you'll have to assume some ratio. Maybe you'll have to assume some coordinates. Okay. So might be, might not be. If without assuming the parameter, you are able to write the equation, then it is very good. I mean, you have got the answer. You are just writing the answer because you are writing the relation between h and k by applying this condition without involving any parameter. So that means you don't need to eliminate that parameter. I hope I hope you are getting my points, Jia and Arun. Am I going fast? Okay. If I am fast, then just let me know. Okay. So apply the given conditions and assume the parameters. Assume the parameters if required. If required, okay. If required, then only assume. Okay. It is not like you are just assuming the parameters as many as you want. Because if you are assuming two parameters, that means you'll have to make three equations to eliminate two parameters. Like if I write one equation, say I'm writing x plus y is equal to a. A is a parameter. Now, how would you eliminate this parameter? To eliminate this parameter, you need another equation. So if I write like x plus ay is equal to b, now you can is equal to 1. Now using these two equations, you can eliminate a. You can find a from the first one and put in the second. But if I involve two parameters like b, x plus ay plus a is equal to ax plus x plus ay plus b. Look, now see, you have two parameters in these two equations. Now you can't eliminate two parameters using these two equations. You can find the values of a and b in terms of x and y using these two equations. Then you need a third equation in which you are going to put these values of a and b. So if you have n parameters, then n plus 1 equations will be required to eliminate n parameters. So just make sure that you are assuming the minimum number of parameters so that you'll have to make minimum number of equations. If you are assuming one parameter, then you'll have to make only two equations. If you are assuming three parameters, you'll have to assume four equations and so on. Okay. So we are going to assume minimum number of parameters. If you are assuming the parameter, then the next step is eliminate all the parameters. Eliminate all the parameters involved, all the parameters, and make a relation in h and k. Okay. Involving constants. Constant is not a problem. Okay. And once you have got a relation in h and k, then final step is replace h and k by x and y. So in like any other equation, your equation of your locus will also be in terms of x and y, because we write all the equations in coordinate system in terms of x and y. Okay, so finally we write the equation in terms of x and y. So these are the simple steps. I'm repeating it, then we are going to practice it. First, assume the coordinates of the moving point to be h comma k. As soon as you come to know that we need to find the locus of this point, immediately assume the coordinates of that point to be h comma k. First thing. Then see, some conditions will be given, some restrictions will be given that this point is moving in such a way. So apply that condition. To apply that condition, you might have to assume some parameter. Okay. So if you need to assume some parameter, assume it. Okay. Assume it. After assuming it, you need to eliminate it. After eliminating it, you'll get a relation in h and k, and that is your answer. Just need to replace h and k by x and y. That's it. Simple. All right. So now let's start. So my first problem is, first example is, find the locus of a point which moves such that its distance from origin is twice its distance from y-axis. Okay, so simple question, very simple. I'll give you some options. You just start finding the relation. This is a very in whole coordinate geometry, locus is a very important point, because in most of the exams you'll find one or two questions from locus always. Okay, so answer your question here. Oh, B and C. Okay. One is getting C, another is getting B. Okay. Let me check. So this was a very simple equation. See, this is say just because you need to involve origin and y-axis, so just make the coordinate axis. And after that, assume your point P to be h comma k. First step. Okay. Now apply the given conditions. To apply given condition, you need to write this PO, distance from origin, is twice the distance from y-axis. Okay, PA. Okay, this is perpendicular distance. Whenever you are writing a distance from a line, it is always the perpendicular distance. Okay, if he is not mentioning perpendicular word, then also you'll assume it is perpendicular distance. Okay, so distance from y-axis. What is this distance PA? PA is basically x coordinate of point P. So that is h. All right, and what is this distance PO? This is under root of h square plus k square. Okay, so to write these distances, you don't need to assume any parameter. That means we do not need to assume any parameter in this equation, in this question. So now we'll apply PO is equal to twice of PA, right? Twice of PA. This is given distance of P from origin is twice the distance of P from C. Yeah, C is the answer. Y-axis. Okay, so it is going to be under root of h square plus k square, n is equal to 2 times of h. Now squaring, you'll get h square plus k square is equal to 4h square, and it is going to be 3h square is equal to k square. See, simple. You just applied the condition, you've got the answer. Okay, and after getting this, now see, replace h and k by x and y. This was our final step. So finally, you need to write 3x square is equal to y square. you will get your answers. In options, you'll get answer in this form in terms of x and y. All right, so I hope you got it. Now let's move to second example. This is very famous example. Now let A and B are 2 points moving on x and y axis respectively. Okay, then find the locus of first midpoint of AB, second point on AB which divides A and B internally in the ratio of 2:1. 2:1. Okay, given that AB is equal to 5. Okay, now try this. This is a good question. Okay, this is the beginning of locus. Make a diagram, proper diagram, and then start your question. And straight lines, this particular question will come a lot of times, a number of times. So once we learn the equation of a straight line, I'll ask you these questions based on this particular question. Then they will say a rod AB is sliding between two perpendicular lines. So whenever they say two perpendicular lines, that means you need to assume coordinate axis. Okay, you can assume any line, any two perpendicular lines. So it's better to assume coordinate axis. That makes our calculation easy. Okay, so this point is going to come a lot of times in various forms. Conditions will vary. Oh, let me give you the answer options. Okay, so options are x square plus y square is equal to 25. Second option is 4x square plus 4y square is equal to 25. Okay, yes, got it. Good. You got it right. Yes. I'm writing the options for other curve also. The second one is x square plus Wait a minute, I'll write the D option here. This is 900 right hand side. Thirty-six x square plus 9y square, okay, is equal to 100. Now let me check. Maybe. Okay. So now this ratio is given 2:1. Okay, 2:1. So okay, first example is we'll have to assume the coordinates of A and B. Why? Because then only you can apply this half angle or sorry, midpoint or section formula. Otherwise, you won't be able to apply the condition. So in this case, you'll have to assume these coordinates A comma 0 and 0 comma B. So and the point P of course H comma K. So if you apply the midpoint, the first question, midpoint, so that is h plus 0 by 2 is equal to a. So h is equal to 2a, and similarly k is equal to 2b. You'll get k is equal to 2b. And one more thing is given, ab. ab means under root of a square plus b square. This is given 25. Okay, this is given 25. 25. Sorry, 5. This is given 5. So after squaring, you'll get a square plus b square is equal to 25. And now put the values of a and b. So it is going to be the a is the first. What was your first answer? A is equal to h by 2 and b is equal to k by 2. Am I doing it right? A square plus b square, h is equal to. Oh, sorry. Oh, sorry. This is, I've written this. A plus 0 by 2. I'm sorry. A plus 0 by 2 is equal to h. So you'll get h is equal to a by 2. H is equal to a by 2. And k is equal to b by 2. So I'll put a is equal to 2h. So a is equal to 2h and b is equal to 2k. So this is going to be 2h the whole square plus 2k the whole square is equal to 25. Okay, so first answer is 4 times of. Now replace x by h and y by k. K by y is equal to 25. This is your first answer. Okay. The second one is, now let's do it on a fresh page. The second one, this ratio is given 2:1, right? This point is h comma k. This point is a comma 0, a point, and the b point is 0 comma b. We have assumed these coordinates. So apply the section formula. So h is going to be 2 times of 0 plus 1 times of a divided by 2 plus 1. So a is going to be 3h, relation number 1, and k is equal to 2 times of b plus 1 times of 0 divided by 2 plus 1 is 3. So from this we'll get b is equal to 2k by 3. All right. Let me check again. Yes, so a is equal to 3h, b is equal to 2k by 3. Now again that relation is going to be same. What was the relation? A square plus b square is equal to 25. Okay. So now put a and b in this equation. So it is going to be 3h the whole square plus 2k by 3. 2k by 3 the whole square is equal to 25. Yes. So your answer seems this is now what, 9 3 h by 3. A is equal to h by 3. I'm sorry. A is equal to h by 3. Okay, so h by 3, 2k by 3. So now it is going to be h square. So 9 h square, not 9 h square, only h square. So it is going to be h square by 9 plus 4k square by 9 is equal to 25. Have I done some mistake? 2 is to 1. 3k by 2. 3k by 2. Yes. What am I doing? This b is equal to 3k by 2. Yes, 3k by 2. And a is equal to 3h. Yes. Let me do the correction here. So this is 3k by 2. Okay. Now it is going to be 9. Now let's take the LCM. So it is 9 by 4. So if you take LCM, it is going to be 4h square you are getting 36, huh? 2 times of b plus 1 time of 0 by 3. So 3k by 2, that is right. B is equal to that. And a is equal to 2 into 0, 2 into 0, 1 into a divided by 3. So a is equal to 3k. That is right. A is equal to, a is equal to 3h. So that was again a mistake. What is happening? So this is 3h the whole square. So 9h square. Now it is right. So finally it is 36 of h square plus 9k square is equal to 100. Yes, your answer is correct. I was doing silly errors. Got it. I was doing this mistake by putting the values of a and b. Okay, so your answer is correct. 36 of h square plus 9k square is equal to 100. All right, so that is the answer. Yes. Now suppose if I repeat this question, if I say that AB the same question, or you can say AB, A and B are 2 points, A and B are 2 points, 2 points on coordinate axis, such that AB is equal to 10, AB is equal to, let's say, 5 only. The same question, now find the locus of foot of perpendicular on AB from origin. Find the locus of foot of perpendicular from locus of foot of perpendicular on AB from origin. That means if you draw this perpendicular from origin and it meets the line AB at P, then you need to find the coordinates of, you need to find the equation of locus of P, okay? Because AB is varying, so P will vary, so obviously it will move on a curve. What is this curve? Try this one. This is a very good question. And this question is going to be very important in whole coordinate geometry. They most of the times they ask locus of photo perpendicular from origin to some or the other line. That line might be tangent, that line might be normal of some curve. So they ask this question: find the locus of photo perpendicular from origin upon a variable tangent of a circle or an ellipse or a hyperbola. All right. So this is going to be a very, very important question now. स्लोप की इक्वेशन और पाइथागोरस यूज़ किया है स्लोप की इक्वेशन एंड पाइथागोरस ऑलराइट okay see if we know the slope and an equation of a straight line. If you use equation of a straight line, then this is going to be a very easy question. Do you know the equation of a straight line? It's a simple one. Line passing through a point and of slope m. This equation. Although we haven't done that, so I have another method. We have a lot of methods to solve this question, but this is a very good method if you use this equation. Okay, if we use this equation, then we can write the equation of locus without assuming any parameters. See how? I'll tell you. First, I'll tell you this method later. First, I'm doing assuming some parameter. So let's take this angle theta. Okay, let's take this angle theta and this OPR. OP we know, this h comma k. So under root of h square. This is method 1. I have assumed the parameter theta and r. So method 1 is under root of h square plus k square is equal to r. So r we know, right? R is nothing but, so h square plus k square is equal to r square. This is relation number 1. Now second is, we need to use this distance AB. Somehow we need to write AB. So how to write AB in terms of r and theta? And because we have assumed two parameters, r and theta, so we need to make three relations. Okay. Can you write OA in terms of r and theta? Of course we can write, because this is a right angle triangle POA. Okay. So this A is going to be r upon cos theta, I think. Yeah, r upon cos theta comma 0. Because this distance is r upon cos theta. OA is nothing but r upon cos theta, right? And this OB is going to be r upon this angle. See, this angle is 90 minus theta and this angle is again theta. So this OB is going to be r upon sine theta. So this coordinates of B, you can write 0 comma r upon sine theta. Okay. Now you can apply this distance formula AB. So if you apply this distance formula AB, then it is r square upon sine square theta, r square upon sine square theta, plus r square upon cos square theta. This is equal to how much it is given? 5. So 25. Okay, so 25. You'll get this. So using this, you are going to get r square. You can take common. R square is known. R square is nothing but h square plus k square. So r square, numerator it is going to be sine square plus cos square is 1, and denominator is going to be sine square theta cos square theta, right? It is going to be 25. So now you'll get sine theta cos theta, because you have got sine 2 theta. This is sine square theta into cos square theta is equal to r square upon 25. Okay, r square means h square plus k square. So this is another relation number 2. Now if we get sine theta and cos theta separately in terms of this r, then we can use sine square plus cos square is equal to 1. Okay, just a moment. I think I have done some. Slope of area is r into this 525 r square sine theta cos theta. This is going to be have we got this stuck or what? If I find sine square theta and then I find cos square sine theta, then where would I put it? That's an important point. Am I missing something? AB is equal to 5 and locus of foot upper vertical. This is 90 degrees, so I assume r and theta. This is theta, then this Slope I think we'll have to use. This distance I have used, h square plus k square. This I have used. But the collinear, these 3 points are collinear. So k upon. Okay, so I think I'll have to write one more relation, and that relation is slope, product of slopes. So this is second relation, and third relation is going to be uh, slope of OP. Slope of OP is k upon h, and slope of AB. Slope of AB is going to be uh, slope of AB is going to be y2 minus y1, so r sine theta divided by r sine theta divided by r cos theta, r sine theta minus 0 upon r upon sine theta upon r upon cos theta. Okay, this with minus sign. So slope of OP into slope of AB is equal to -1. So from this we'll get another relation. Minus minus will get cancelled. R and R will get cancelled. R and R. Okay, and we will get cos theta will be okay. So you can send it right inside. So tan theta will get tan theta is equal to k upon h. Okay. So from this equation we'll get tan theta. And if we are getting tan theta, then we can write sin theta and cos theta also. So sin theta is going to be what is sin theta? Sin theta is going to be k square upon k upon under root of h square plus k square. And cos theta is going to be h upon under root of h square plus k square. All right. Now we can write sin theta. We can put sin theta and cos theta in equation number 2. Okay, so put in this equation. So it is going to be we can write sin theta cos theta is equal to sin theta cos theta. We can write sin theta cos theta is equal to r upon 5. Okay, square root ले लिया. Now we can put sin theta cos theta. So sin theta cos theta की value put करेंगे. So it is going to be k into h upon under root of h square plus k square into under root of h square plus k square is h square plus k square, and this is equal to r is what? R is under root of h square plus k square divided by 5. Okay, so this is what we are getting. If I square it, so final answer is going to be 5 times of h comma k is equal to h square plus k square power how much? 3 by 2. Okay, we can square this equation. So I think this is the answer. I'll check it through other method also. There might be some calculation error, but method is right. Have you got the method? First we have written r is simple under root of h square plus k square. Second, we have what we have done. We have written the OA and OB in terms of r and theta. Okay, using right angle triangles. And then we have applied distance Pythagoras. So we have got relation number 2. And after getting relation number 2, we have used slopes. Okay, and after getting these slopes, we have multiplied using if two lines are perpendicular, then product of slopes is going to be -1. We have used that point. So we have got tan theta in terms of h and k. If we have got tan theta, then we have got sin theta and cos theta also. Okay, so this is one of the method. Now let me tell you the simple method, second one. If because we are, but in this you'll have to use the straight lines. Okay, so this method will be clear to only those students who know the equation of straight lines in this form: y minus y1 is equal to m x minus x1. This is an equation of a straight line passing through x1 y1 and of slope m. Okay, so in this method, the method number 2, we do not need to assume any parameter. Okay, see how. First of all, we are going to assume the parameter coordinates of this point P to be h comma k. Okay, if coordinates of P are h comma k, then we can write the slope of OP. So slope of OP is going to be k upon h. Okay, k upon h. This is 0 0, that is h comma k. So k minus 0 upon h minus 0. Now we can write the slope of AB. Slope of AB. So slope of AB is going to be minus 1 upon m, the slope of OP, right? So that is minus of h upon k. Have you got this point? So now you know we have got the we know one of the coordinates of line AB and slope of AB line. Okay, so we can write the equation of AB. So now we are writing the equation of AB. Equation of AB. So equation of AB is going to be y minus k, because line is passing through this point. So y minus k is equal to m is minus h upon k into x minus h. Okay, so this is equation of AB. Now in this equation of AB, after getting this equation of AB, we are going to write A and B, coordinates of A and B in terms of h and k. If we get coordinates of A and B in terms of h and k, then we can apply Pythagoras and we'll get, because AB is given, length AB is given, so we can write length AB. Okay. So let me simplify this equation, or maybe for point A, because point A is on this line, and x coordinate of point A is 0, sorry, y coordinate is 0, so we put y is equal to 0 in this, and we'll get x coordinate. So if you put y is equal to 0, you are going to get k square plus h square, k square plus h square upon h. Okay, have you got this point? Have you understood this point, both of you? Now we'll write the coordinates of point B. Okay, so coordinates of point B, for coordinates of point B, x coordinate is 0, so you put x is equal to 0. If you put x is equal to 0, then y is going to be y minus k is equal to h square upon k, it will be, right? Then y you will get h square plus k square upon k, so it is h square plus k square upon k. Okay, so now you can see, now we have got A and B coordinates without assuming any parameter in terms of h and k completely. And because we have got A and B, so we can apply AB is equal to 5. So AB is given 5. So AB is given 5. That means A is nothing but square kar do, square of this. So it is k square plus h square upon h the whole square plus k square, h square plus k square upon k the whole square is equal to 25. Okay, simple. Got it now? A square plus B square is equal to 25. This is your A, this is your B. So now I'll get h square plus k square the whole square common, and it is 1 upon h square plus 1 upon k square is equal to 25. So yes, the answer was right. That previous calculation was also correct. So it is h square plus k square the whole square, and if you take LCM, it is h square plus k square divided by h square k square, which you can send right hand side. So h square k square. So it is h square plus k square whole cube. Okay, h square plus k square whole cube is equal to 25 h square k square. In the previous one also, it was h square plus k square whole cube. Okay, just do the squaring, you'll get h square plus k square whole cube is equal to 25 h square k square. All right, so you have now two methods. Got it now? This was a very good question. Okay, one last question quickly. Now, one last question. Question is, find the locus of point of intersection. It's a very simple question. Point of intersection of two variable lines. One is L1 x sine alpha minus plus y cos alpha is equal to 4. The second one is, okay, this is and wait a minute. Okay, and the L2 line is x cos alpha minus y sin alpha is equal to 3. Now, alpha is a parameter, okay? Alpha belongs to R means alpha is a parameter. So this is the question. It's a very, very simple question. Just mentioning it here. Sometimes they ask the locus or point of intersection of two variable curves because two curves are varying, so their point of intersection will also vary. And if their point of intersection will vary, so it will be on some curve. So we need to find the equation of that curve. So I'm giving you the options. Options are x square plus y square is equal to 5, and then x plus y is equal to 25. C option is x square plus y square is equal to 25, and D option is 1 upon x square plus 1 upon y square is equal to 1 upon 25. Okay, so you have a parameter alpha to eliminate, already given in the question. You can't do anything about it. Yeah, you guys got it. Very good. So it's just elimination of alpha because h comma k lies on both the lines. So you can put, see, you have assumed point P, h comma k, then apply the given condition. This is the first step. I'm repeating all these steps of locus. Now the second step was to apply the given condition. What is the given condition? That this is the point of intersection of the given lines. That means it lies on both the lines because equation of lines are given. So we will put this point on the equation of lines. So first if we put this point on the first equation, so it is going to be h sine alpha minus k cos alpha is equal to 4. And to put this point, we do not need to assume anything. Just put it. Already parameter is given in the equation. So we'll get two relations, h cos alpha plus y, k. This is a formality. In this question, it is a formality to put h and k, because sometimes students get confused if I directly eliminate alpha and write a relation in x and y. They just get confused why we are writing a relation in x and y and why this relation is representing the locus. Because if I directly say that square these two equations and add and eliminate alpha, then you'll get a relation in x and y. That x and y is basically the common point of both the lines. See, in this equation, the xy written in this equation is a point moving on this line, okay, moving on this line. The xy written in another equation is a point basically moving on this line, okay. If I talk about a common xy, the same xy, which we will get actually by eliminating alpha, that xy is basically lying on both the lines. That means it is the point of intersection, okay. So it is an important point to understand. But sometimes students get confused in that. So I'm writing h and k separately. That's why. Sine alpha is equal to 3. Now we can clearly see that h comma k is a common point, right? So h comma is satisfying the first equation and the second equation, h comma k is the point of intersection. Now you can eliminate alpha. So you can eliminate alpha by squaring and adding these two equations. First and second, square and add. First square plus second square. So in such equations, directly squaring and adding will eliminate alpha. So you'll get h square sine square, h square cos square. So it is h square sine square plus cos square plus k square cos square plus sine square. and minus 2hk sin alpha cos alpha plus 2hk sin alpha cos alpha will get cancelled, and right hand side it is going to be 16 plus 9. This is 1, this is 1, so finally you'll get h square plus k square is equal to 25, and the final answer is x square plus y square is equal to 25. All right. So this was the locus. Okay, we'll do problems based on locus after learning some equations of straight lines and some other things, and we'll keep doing locus in all the chapters of coordinate geometry. Okay, so today I'm ending the session here. All right, Gia, we'll continue tomorrow. Tomorrow I'll teach all forms of straight lines. I'll try to understand intercepts, slopes. Okay, so tomorrow I'm going to finish all the basics of straight lines. All right. And after doing a few sessions on straight lines, what we will do, we'll plan a practice session of very good questions on in a special class. Okay, so there we'll do practice sessions of straight line questions. So in that way, we will be able to finish straight lines within maybe 10 days. Then we'll start circles. All right. Chalo. Okay. Thank you very much. Thank you for attending this session. All right. Take care. Bye bye.